All right, cool. So let me get this pen. So from here, you just see that, okay, we now go to 5 point. Let me just get the, what you call this, the question paper again. There we go. This is 2023. It's not what I want. Okay, let's do this. It's actually the campus that's calling me here now. Oh, 2023 is actually what I want. Ah, goodness. How did I forget that we were actually doing? I think it was that conversation around the. Okay, right, cool. So we were on question 5. Question 5.2. Right. Yeah, here we are. Right. So 5.2, what were they asking? They were saying construct a group frequency distribution table for this data set. Your table should include columns with descriptive headings indicating the frequency count values and the percentage frequency for each class. Okay. The total for each of the later columns should be indicated. Use 25 to 30, 30 to 35, and so on. So they're actually helping you to then establish the intervals of each class, right? Okay, so here you can see, first things first, you need to establish the different classes that you have. So I think the first thing that you want to do is obviously organize your data in such a way that you can obviously see from the smallest value all the way to the biggest value. Okay. Fortunately, again, they've ordered the data for you, so you don't need to order it from smallest to biggest. Okay. But before we go on, let's just see. They say the following data set indicates the number of people per day who made a cash donation to a local spinal cord injury charity over a random sample of 20 days. Okay? So the number of people that have made a donation to a spinal cord injury charity, all right? And then they're asking us, just for the benefit of those who just walked in, to construct a group frequency distribution table for the data set. The table should include columns with descriptive headings indicating the frequency, count values, all right? Frequency count values, so here you can already see, once you've gotten your classes, they've already started to give you your frequency values, okay? And then, and the percentage frequencies for each class, okay? So what percentage of all our data is in which class? Then the total for each of the later columns or latter columns should also be included. Use classes 25 to 30, 32, 35, and so on. Okay, so here you can see we've already put together our classes. Okay, and then we went on to say, oh no, I'm looking at the wrong. Goodness me. It's a sign. I must go and sleep. Here are your classes. Okay, there are your classes, and then we go on to say, okay, which data points are in which class. There you can see. And from that, we then can conclude we have 20 data points, okay? And then we go on to calculate the midpoints, okay, of each. And there you've got your frequencies. Can you see we had 2 observations in the first class, 2 observations in the next, and then 5. Is that 5? Yes, that's 5. Here, why did we write 4? And then 1, 2, 3, 4, 5, 6, 7. 7, we got that right. We're happy with that. Here, 1, 2, 3, 4, 5. We got that right. So here, I don't know why we don't have 5. And all of those data points should be there. Okay, so just be mindful of that. I'm just going to scribble it out. Okay, and then is it? It's just me. It is just me. Yeah, it's the heat. It's the heat. It's the heat. You see what she mentioned first? Yeah, what she mentioned first. Okay, so everything is in order there, and then obviously just calculating the percentages, which you can see they've done over here. Okay, so literally it's okay. We have 2 out of 20. Yeah, you guys know how to. We've been doing that since primary, ne? Percentages. So it's fine. So there's your. I just want to take a moment to just actually really have a look at that. There's your group frequency distribution table. Okay. So it's pretty much like the other frequency table that we had. The only thing is now here we have percentages. They can also ask you to do the cumulative frequency as well. And remember, cumulative, we're just saying, okay, the first class, let me do this so that we can see this. So I'm just splitting this column, isn't it? And here I'm just going to say cum. Okay, so the first class will be the same. But moving to the next class, you need to add what you had previously and what you have in that specific class. So this is going to be 4. And this is going to then be 8. No, not 8, 6 actually. 6 plus 4, which gives you 10. Sorry, guys. You were complaining about accounting. I had accounting earlier. Then the next is obviously going to be 17. Isn't? Next one is going to be 5 plus 17. What do you get? 5 plus 17 is 22. Your face is telling me the maths is not matching.
So is it not 4 plus 4? It's 8. Are we adding 2? Are we adding 2 and 4 plus 2 is 4, then 4 plus 4 is 8. Then 8 plus 7. How do you add cumulative frequency? What is the proper way of adding this? Is it everything previously or just the row?
Everything previously. It's everything previously.
20. Okay, so there's 6. 14.
But can you see, if you want to double check whether you did things properly, the total you have here must be the total that you get on the last class. So that's a nice quick way to double check. Is it making sense?
Yes.
Because we can't have more variables than what we have as a total. Can you see that? All right. I was just testing if you guys were paying attention. It was just an experiment. I was just testing. Okay, so here now, again, you can see they've given us what? This cross or contingency table. And they've asked us to calculate specific probabilities, all right, within that table. So one thing we know is that they like this type of question, okay? So I'm just going to read the different things they asked, but I'm not going to go into it again because I think we've exhausted this. So let's quickly see here. The first thing they ask, maybe just in terms of the scenario here, results, okay. The following contingency table gives the results of a sample survey of South African male and female respondents with regards to their preferred financial provider. So they just changed. Last time we were talking about grocery stores. The other time we were talking about, I can't remember what that thing was. Versus takeouts, you know, your fast food chains, and so on and so forth. Deodorant, okay? Right. So here now it's obviously your financial institution. So here, what is the probability of a randomly randomly selecting a respondent from the sample who prefers momentum? Okay, so obviously that's the total who prefer momentum divided by the total number of respondents. Okay, so we've seen that before. No problems there. What is the probability of randomly selecting a respondent from the sample who is not male? Okay, again, here we know there's two ways we can calculate it. Fortunately, we only have males and females, so we can just take the total of females over the total respondents. Okay, or we can say 1 minus the number of males divided by your total respondents. Okay, if we have, remember there's him, her these days, and there's them, and yeah, so if we have that mix, then we know it'll be easier just to say 1 minus that probability. Okay, this now the third one here, they're saying what is the probability of randomly selecting a respondent who is female and prefers mutual and federal? Okay, so here can you see this is not a conditional, this is a joint. Sorry? Yes, we are multiplying. Okay, well, we would have multiplied. Well, you can do it one of two ways. You can multiply if you want to, but because we have this contingency table where we know how many female and how many prefer that, so we can just go there and see and get that 130 and say divided by your total number of respondents. Okay, but if it was separated, and I'm struggling to give an example, then you may need to times. But whenever we see and, it is a multiplication probability. Okay, right. So that's how we then get that probability there. Last one, at least in relation to the contingency table, they say, what is the probability of selecting a respondent who is male, given that they prefer clientele? So here we know it's a conditional. So we know that the formula there is, what is the probability of A given B has occurred? So here we know we're saying number of male respondents who prefer clientele divided by the total number of preferred clientele respondents. Okay, and so instead of saying, if we look at our contingency table, we're saying males that prefer clientele, boom, there we go, divided, not total, but total, yeah, sorry, yes, total clientele respondents, not total respondents. Okay, right. Happiness there. Right. And then here, if we look at 6.2, they're taking us back again to the same question that we tackled yesterday. They're saying event A and B are such that the probability of B is equals to 0.10, and the probability of A union B is 0.65. Given that A and B are independent and non-mutually exclusive, determine the probability of A. Okay? So again here, guys, make sure you know this, because they clearly like this question. They clearly like this question. So here you can see the breakdown of how we then got the relevant formula, that being probability of A union B. Okay? That was the relevant formula. And we know because this is, and so that's the probability of A plus the probability of B minus the intercept. All right. And we went into yesterday why we're saying minus this intercept, so that we don't duplicate, isn't it? And we know since these are non-mutually exclusive or independent events, this P intercept A intercept B is the same as saying probability of A times the probability of B, because they are independent events. Okay, so then we then now just need to substitute into our formula. Okay, we know what the probability of A union B is. They gave it to us, 0.65. We don't know probability of A. That's what we want to figure out. But we do know the probability of B, which is 0.1. So we plug that in there, and we plug that in there. And then we obviously just solve for A. We need to isolate A, the probability of A, and then establish what the probability of A is. And there you can see we do exactly that. And finally, we come to 0.611 or 61.1%. Okay. Here they didn't ask you to leave it as a percentage. Okay. But yeah, so if you left it like that, that's fine. The last thing they asked for 2023, at least pertaining to the units we covered for test 2, is to draw a Venn diagram to illustrate the intersection of two mutually exclusive events, A and B. Okay, and this is what we are looking for, the intersection. Okay, and that's all they asked for. That's all they asked.
Are there no numbers?
No, they just asked for us to show a Venn diagram. They didn't give us any numbers. And here they said of two mutually exclusive. Yeah, they didn't give us any numbers. So what I would advise, go to your learning unit 5, probability distribution slides, and you're now starting to see the key things that you need to know, like things you need to interpret. Also learning unit 4 and unit 3. And so you must be able to draw these Venn diagrams and things of that nature, be able to interpret certain things. So just go over that before you. Yes. No, I'm not testing your drawing, isn't? I'm not testing your drawing. I'm testing what? Your knowledge, your understanding on statistics. So I don't care if it's messy, but at least I must be able to see what's going on. Ne? So yeah. So the only thing now that we want to do is to quickly look at 2022 suggested or questions. So here you'll see it's much like what we did with 2021. Okay, man. Okay, this one, let me do this. Let me not share the screen. Okay, so here again, they've given us a contingency table. Again, now they're looking at I think this is the one I was actually referring to mentally. They're looking at your preferred fast food outlet, and they're asking the same questions. What is the probability of randomly selecting a respondent who is male and prefers Burger King? Can you see? It's a joint probability. Okay. So.
Oh no.
Exactly. 100%. But again, if it wasn't a contingency table, that what you guys have been mentioning is exactly what we would do. We would need to know what the probability of getting a male. I just want to quickly answer this, and the probability of them being having a preference to Burger King. So but because we have a contingency table, we can look that up for both males and Burger King. Does that make sense? But otherwise, had it not been, we'd have to do the times. And we'd need to know the probabilities of both potential events. Okay. You wanted to ask something?
I would have said 60 over 1
Over 1?
Then the question would have been inverted. How many males inverted?
Yeah, how many males? What's the proportion of males who prefer Burger King? Because we're looking at the respondents, all our respondents. Okay. So that's the first one. The second one, what is the probability of selecting a female respondent given? The moment you see the word given, you know you're dealing with conditional. Because we're saying this condition must be met before we find a female. Okay, so here they're saying given that the preferred fast food outlet is KFC. And this is where now we say, okay, the probability of this respondent being female and preferring KFC, what is it? 50. Sorry, I'm looking at Burger King. 100. But now, because it's a conditional, we say, given that she prefers KFC, isn't it? So it must be out of 150 and not all respondents. So we'll then pick this as our denominator, which is what they've done here. So this is just, it's a matter of practice. And English, once you get used to the different terms that they use, you immediately know, okay, this is what they're alluding to, what they want me to do. Am I dealing with conditional? Am I dealing with? So here now, they're saying, what is the probability of selecting a respondent who is female or prefers McDonald's? Can you see we had a similar question like this yesterday as well? And we know when they say, oh, we know it's a additional situation. Yes?
When they say and or.
And is and or. I've never seen that one. I've never seen that one. Where you have like it's kind of like I haven't seen that one. I don't know if you can bring a question then maybe. But I haven't seen that in your workbook. I haven't seen that in any of the papers. But it reminds me of where we say, what is the probability of at least getting 1 day or more? Or at least getting 1 day. There you're looking at the probability of anything that is 1 or more. Isn't it?
Is that in the probability that's in the test? No, and more. No.
At least. Those probabilities, we have been primarily seeing them in sample distribution. I haven't seen them in basic probability. But just double check. Just make sure. Just make sure. Just make sure. Guys, like I told you, you revise what we've revised from your past tests and your past exams. You revise what is there in your revision exercises. Trust me, you'll be fine for test 2. You will be fine.
They're not asking much about Bayes' theorem.
Bayes' theorem?
Yes.
What is Bayes' theorem? Remind us. Okay, so anyway, whilst she looks that up for us. So remember, we're looking for female or who prefers McDonald's. Okay, so again, we are looking at the probability of females, respondents. What total females is? 270, isn't? We want the probability of the respondent being what? Female or. We have a total of 270 females, isn't? And then we divide by your total respondents. We have we have two probabilities, isn't it? So firstly, we're starting with the respondent being female. What is the probability of the respondent being female? So we're saying 270, we have 270 females who have done this survey, right? Then divided by the total number of respondents, which is 400. Okay, that's your first probability. Then the second probability is the respondents being or preferring McDonald's. This can be male, this can be female. Okay, so how many prefer McDonald's? We have a total of 140. Can you see that? Again, 140 of 400 respondents. Okay, so you're saying 140 divided by 400. Can you see that? But then we know that when we have joint probabilities, all right, or when we add probability, there is the risk of duplication. Because in that 140 that prefer McDonald's, some of them are female. And we've already said, we've already included all of our female respondents. So we're saying we need to then remove the female and McDonald's preferring respondents. So we need to then go to our table and say, how many are female and prefer McDonald's? 120. And then over obviously 140. And we then, that's our probability there. Can you see now we've got our total female respondents. We've got our total who prefer McDonald's, and then minus the females that prefer McDonald's, so we don't duplicate. And so our probability is 0.725, which is the same as 72.5. That's the probability of selecting a respondent who is female or prefers McDonald's. Right. Then here, you can see again, they've asked us, events X and Y are such that probability of X is 20 and the probability of X union Y is 55. All right, percent. I'm talking percentages, but you know it's the same as if we were to do decimals. Given that X and Y are independent and non-mutually exclusive, determine the probability of Y. This is the same thing that we did. And again, what we need to do here is isolate your probability for Y. And once you've isolated that, you can then determine the probability of Y, which will then give you 0.4375, which is the same as 43.75%. Okay, so I don't need to stress it enough. Sorry, I can't stress it enough. Make sure that you know that question, because they could very well bring it. Okay, then here they are bringing just two questions that they have not asked us in the other questions that we've looked at thus far. Here they are testing you on your combinations and your, what do you call that thing? Permutations, probabilities. Okay, so here they say Helen is a manager of a financial department. She has 15 members of staff working for her. Okay, she has to choose 5 members of her staff for a research team. 5 members for a research team. Okay, how many different teams can she select from the 15 members of staff? Can you see order doesn't matter here? The difference between combination and permutation is order. With permutation, we need to know the order, or we're concerned about the order. With combination, we don't care. We just want to know how many different orders of 5 members for research can we have? Does that make sense? So here, again, there you can see your formula. You've got the number, all right, total number that we can select from, and then combinations of 5. That's what your R is for. Number of objects selected at a time. Okay, we can only select 5 in our research team. Is it making sense? Okay, so there's your formula. You're literally just plugging in 15 exclamation mark divided by 5 exclamation mark 5 minus, sorry, 15 minus 5 in brackets exclamation mark. All right, and then you obviously get a total of 3,003 different combinations of 5 research members. Okay, so here, of course, they can ask you to interpret. Did they ask us to interpret? They didn't. Okay, but that's your interpretation. So that's the first thing. The second one now they're testing us on permutations. Okay, or permutations, depending on where you come from. All right. Yes. But I know this one is easy. Why? Why is it easy? We also did this in primary.
Exclamation mark in primary.
No, I'm joking, guys. I'm joking. Okay, so here it says there are 12 teams in a basketball league. All right. What is the probability of correctly predicting the top 3? Correctly predicting the top 3 at the end of the season in the correct order. Okay. The moment you see a concern for order, you know this must be a permutation. Okay. So there you can see the formula is slightly different. We don't have. If I just scroll up, zoom out a little bit. Can you see? The formula is slightly different. Okay. And in your calculator there, you can see it's NPR. I've never tried to use the calculator. I usually just break it down with the exclamation marks. But you guys can play around with that as you prepare for your test. So here, remember, they're asking what is the probability. Okay? They're not just asking for the number of combinations that you can have where you select the right order. Okay? They're asking for the probability. So, yeah, what is the probability of correctly predicting? So once you get your combinations or your number of permutations, right, you say 1 divided by total possible outcomes. Okay, so first things first, 12 is the total number that we can select from. We want 1, 2, and 3, correctly predicting that order. So 12 minus 3, and then boom. All right, so the number of different ways that we can obviously correctly predict that is 1,320. So 1 divided by is then giving you the probability of 0.007576. And if we put this in a percentage, so that would be 0.07. 576%.
So why are we dividing 1 by 1?
Because remember, we have total, our probabilities all add up to 1, isn't it? And that's as far as my explanation bundles can go. So I don't know how else to explain it past that point. So here, as I was saying, 7.576%. If you wanted to leave it as a percentage. If you wanted to get it as a percentage. So guys, that is your school fees for today. Your school fees bundles has been depleted.